Okay, so here we have a continuation of what we started yesterday. So we've got integrated 1, so that's us, and then we've got 1.1.1 continuation. We're going to talk more about being able to stack functions. So really a large part of today is going to be what can I do and what can't I do when it comes to like rearranging and ordering my stacking functions. So if we take a look at this continuation from yesterday's question number 5, so using what we know about integers. Now specifically, I'm talking about positive and negative. So maybe some fractions might creep up today, which is okay. Maybe some decimals creep up today, which is okay. But it really is like some knowledge of functions and what they can and can't do. So we have these 3 function machines. We've got F, G, and H. And we know for sure that we're going to stack all 3 of these up in some order, whatever it may be. What we're going to drop into the very top is 0. Then it's going to bounce through the other machines. And at the very, very, very end, it's going to spit out negative 31. Knowing that, we want to try to figure out which machine can't be last. So what can't go third? But we are talking about an output. So I'm going to put a little note over here off to the side. So we want to know which of these functions can't have an output of negative 31. And now we are talking about an output specifically. If we're talking about an output, it's what the functions are equal to. So, for example, we'll take a look at the first one, just kind of get our brains in the right spot. So if I take a look at f of x, I'm going to color code that guy green, and then I'll color code all of its work with green also. I'm trying to determine is, can f of x be equal to negative 31? That's ultimately the question. So I want to take my f of x function, which is 4x minus 32, and I'm going to set it equal to negative 31. And I'm going to ask myself, can I solve for x? So that's my question here. So is it something that is absolutely possible? Well, I think so. So let's go ahead and solve for x. It gives us a little bit of practice with equations that you and I did last week as well. So find the equal sign. I'm going to go ahead and just split down there. And remember, your goal is to get the x's on one side of the equal sign by themselves and everything else on the other side. So I see a 4 that is stuck to the x, and I see a minus 32 that's kind of hanging out afterwards. That's addition and subtraction is the 32, and we're going to get rid of that guy first. So let's go ahead and add the 32 to the other side, just to get negative 32 and positive 32 when I add them to cancel. Drop down the 4x and the equal sign, and then I'm going to add negative 31 and positive 32, and that's going to give me 1. Okay, last thing I need to do is get the x by itself. So I'm going to divide by 4. And then 4 divided by 4 is 1, so those cancel. And then I have no idea what 4 can't go into 1 evenly. So I'm just going to leave it as 1/4. So I guess the question is, was f of x allowed to be negative 31? So I set it equal to negative 31. And then I went through the work and was trying to determine if it was even possible. I got an answer. I got x equals an actual number. So I think my answer here is yes. Yes, this can happen. So yes. So I go back up to where f of x is, and I'm just going to write a little note. So this could be. I don't know that it's guaranteed, but this could be the third machine. So what we want to try to do is we want to try to figure out if we could, like if this is the case with all of them. So let's check the next one. So I'm going to go ahead and put a box around that guy. Let's do blue this time. I'm going to take our g of x function, and we're going to ask ourselves the exact same question. Can g of x be equal to negative 31? So we're just trying to figure out if it's even possible. So can g of x be equal to negative 31? So let's do the same thing. So we're going to take our g of x function, which is x minus 2 squared, and we're going to set it equal to negative 31. And I'm going to ask myself, can I solve for x? Well, I want you to give that a little bit of thought and see what you think. If we take a look at the left-hand side of this, we have the parentheses squared. I'm just going to think about what squared means. So basically what the left-hand side says. So what this says over here is that something, I don't know what the something is, that's what we're trying to figure out. Something squared is equal to negative 31. Okay, so let's think about what squared means. Squared means times itself. So something times itself has to give me negative 31. Okay, so this means something, whatever that is, times itself has to equal negative 31. Okay, I'm having major concerns at this point because I think about what we know about positive and negative numbers. So this is my whole integer part coming in. If I think of something, let's say I think of a positive number. So I've got this positive number times itself. Well, if you times it by itself, it's a positive number also. So a positive number times itself is going to have to give me a positive number. That's not going to work. So it can't be a positive number. But what if it's a negative number times itself? Okay, well, negative number times itself, that's still positive. I think the only way to get a negative number is to do different signs. But this is not something times itself. But this breaks the idea of something times itself. So I can't do that one. But that's the only way I'm going to get a negative number. So I think the only options that I have here are going to result in a positive. So can I solve for x? No, I can't. I don't think this one's going to work. I think that this right here, something times itself giving me a negative, this is not possible. And because it's not possible, I'm going to go back up to where the g of x function is, and I'm going to say, no, this can't be the third machine because I can't get a negative number out of it. So, can't be the third machine. Okay, Now, I think that's the hard one. H looks a little funky, but I don't think it's necessarily all that more challenging or easier than the other one. So let's take a look at the H function because maybe it can't go last either. All right, well, let's check. So, can H of X equal negative 31? Well, let's check. So I'm going to do the exact same thing. Well, H of X is 1 over X. I'm going to set it equal to negative 31. And I'm going to see, can I solve for X? And now this takes me back to something that you guys did in previous class. I think it was 2 years ago, maybe last year. If we have one side of an equation looks like a fraction, and the other side of the equation, if it looks like a fraction, then we can cross multiply. However, it doesn't look like a fraction right now. So I'm going to make the negative 31 look like a fraction. I'm going to put it with a denominator of 1. So what I'm going to do, now that I have a fraction on the left-hand side and a fraction on the right-hand side, I'm going to cross multiply. So I'm going to multiply diagonally. So I'm going to do 1 times 1. That's going to give me 1 equals. Now multiply the other diagonal. It's going to give me negative 31 times x. And if I multiply those two together, that gives me negative 31x. Now, the beautiful part of cross multiplying is that the fractions are gone, which is really nice. Now, we're back to a pretty basic equation. See that the x is on the right-hand side. The only thing that needs to go away is the negative 31. The negative 31 is stuck to the x as a multiplication. So we're going to divide. So I'm going to divide by negative 31 on both sides. Go back to my purple pen, keep my color coding. So negative 31 divided by negative 31 is 1. And I get x is equal to, and I have 1 over negative 31. That's a number. It's not necessarily a number we like, but it's a number. So did I get an answer for x? Yes. Yes, I did. So going back to the h of x, this one could be the third machine. So based off of what we know, we are able to eliminate G as the last function machine. So which of the function machines can't have an input of 0? So basically, can I plug 0 in for x? Okay, so can I plug in x equals 0? Because remember, x values are our inputs. So let's go through, color code these guys. And let's take a look at the first one. So I'm basically just starting again, but instead of setting the function equal to a number, I'm plugging a number into the function itself for x. So let's take a look at this guy. I'm going to go ahead and say, can I plug in x equals 0? So I'm going to go to my f of x function, but everywhere I see an x, I'm going to cram a 0 in. Okay, so now at this point, can I solve? So Am I allowed to get a number out of this if I do all of the work? Oh, I don't know. Let's try. The left-hand side is notation only, so let's leave it as f of 0. So don't touch that side. All we're going to do is clean up the right-hand side. So if I do 4 times 0, that gives me 0. Bring down my minus 32. You guys know how I feel about that. So I'm going to move this guy up and make it a negative sign instead of a subtract. If it doesn't bother you, then don't worry about it. You don't have to move it. It bothers me, so I move it. So then I have 0 plus negative 32. I go ahead and finish. 0 plus negative 32 is negative 32. So the question was, could I plug in x equals 0 and get an answer? Yes, I could. I got an answer. I got negative 32. So this is yes. Okay, so let's go back up here. So f could be, I don't know that it is, it could be the first machine. Now I have to do the exact same thing for the next one. So I'm going to go ahead and color code that in blue. And we're going to ask ourselves the exact same question. So, could I plug in x equals 0? So, go to my g function, and everywhere I see an x, I'm going to plug 0 into it. And then why don't you guys see if you can go through and figure that out, if it's possible. We don't know yet. But if you can do the math, do the math. Remember, the left-hand side is just notation, so don't touch that part. Okay, so if we go through this one, let's see. And I saw a whole bunch of correct answers. Really good job, you guys. We know, so leave the left-hand side alone. It's just notation. We know that 0, okay, you know how I feel about that. I would turn that into 0 plus negative 2. But I know that 0 plus, negative 2 is actually negative 2. But remember, squared means times itself. You might want to actually write them out just in case. So we'll get negative 2 times negative 2. Okay, now I feel pretty good about the sign being positive and the answer is 4. So can I? Yeah, yes I can. So this is a yes. All right, so let's go back up to G. This could be, doesn't have to be, I don't know for sure. This could be the first machine. Could be. Okay, I think the last one we need to check is h of x. So let's do purple on that one. And I'm going to go through and just ask myself the exact same questions again. So can I plug in x equals 0? All right, well, let's check. So I'll do h of 0 is equal to 1 over. Now, I like using parentheses when I plug stuff in, just as a habit. And then I look and there's nothing else around it, so I don't really need it. So I'll go ahead and rewrite this as h of 0 is equal to 1 over 0. All right, I'm going to go with your phone is probably close-ish to you. If not, I know you've got your Chromebooks because that's how we're here together. I want you to type this in your calculator and see what happens. So type in 1 divided by 0. And let's see what we get. Yeah, it's weird. It doesn't give you a number. Like, the word error is not a number. So I think we've got problems here. We've got big problems. So our calculator says that this is an error, which I completely agree with. Here's how I knew this was going to be an issue. Division itself is really another way of writing out a multiplication problem. It's just kind of like addition and subtraction. So what this is saying, this says that 0, the denominator, times something. I don't know what it is. So times something has to give us the numerator of 1. So at this point, 0 times something has to give me 1. I can't think of a single thing in this world that if I do 0 times it, I'm going to get 1. Every single time I take a number and I times it by 0, I'm going to get 0 for sure. So this thing, that's impossible. That can't be done. So what we're going to do, so take a look at that statement there. So 0 times question mark equals 1. This is a false statement. It cannot be done. What we're going to do is we're going to turn that equal sign into a no equal sign. So we're just going to put a slash through the equal sign. So since it's impossible, we put a slash through it. Then we go back up to the h of x, and we've now ruled it out as the first one. It can't go first. So this can't be the first machine. Now, what some of you got on your calculator, it didn't pop out an error message for you. It actually popped out infinity, which still is an issue because we're looking for the answer to be a number. Infinity is not a number. Infinity is the idea that there are more numbers out there. Infinity is the biggest number you could possibly imagine, and then more. So if somebody says to me, the biggest number that I can imagine is 500 billion, trillion, zillion. And I say, okay, I can think of a number bigger than that. Because all I have to do is add 1. If I just keep adding 1 to your biggest number, then we're getting bigger and bigger and bigger. So even if your calculator gave you infinity as an answer, that's still not a numeric answer. That doesn't make any sense. Here we are, the exact same 3 functions. We have already eliminated which one of the functions could not go first and which ones could not go last. Now we're going to actually try to find the correct order. So on this, make a little note to ourselves here. I think we eliminated, so if we plug in a 0, all right. So h of x can't go first. All right, so that one can't be first because we can't plug a 0 into it. And then g of x can't be third. But we do have other options for the first. So if h can't be first, maybe f or g could be first. We didn't even talk about the middle, so they're going to have to play around with that. And then g of x cannot be last, so we can have f or h last. So we need to figure out the order in which we're going to stack these things. So here's what I'm thinking. We're going to have our function machine, and then we're going to take that and we're going to dump in the answer from the previous function machine. Then we're going to take that answer and we're going to dump in the answer from the previous function machine. So we're going to have like this like little trickle down effect happening. So we have to figure out though which one goes where. So remember at the very, very, very top, we're going to dump in 0. So that's going to go in for x. Then whatever answer comes out of that, is going to get dumped into the next machine. So whatever comes out here gets plopped into the next one. Then we need to get an answer from that machine, and that's going to get plopped into the next one. And then at the very end, we know what we want because we're being told that the final output is negative 31 at the end. So what I'd like you to do at this point is start playing around with the orders and see if we can find it. If you find one that you tried that does not work, so let's see if we can do process of elimination. If you find one that does not work, type it in chat so that everybody can see it. If you find the one that does work, hold on, because we want to give everybody the opportunity to see if they can come up with the correct order. So one of the things that you could do, and you don't have to do it this way, but I know me, and I know that if I just try to like randomly pick orders, I'm going to keep checking the same ones over and over and over again. And then I feel like that's a waste of time. And then I'm going to get frustrated. I don't want to do that. So what I would do is write out my possible listing orders. So I could do F, G, H, but I tried that and this didn't work. So that was a no. Then I would still leave the F first. So I'm trying to fix one of them. And then I'm going to flip the H and the G. But that doesn't work because I can't have G last. So I take a look back at my notes. F could be first. H cannot be first. So maybe now I'm going to try G first. So maybe I try G, F, H. I don't know. Let's give that one a shot. So I'm going to plug 0 into the G function first. If I plug 0 into the G function first, and I'm using my calculator or doing the work on my scratch paper, I think I'm going to get if I plug 0 into G, I get 4. So I get 4 there. But now I'm going to take that 4 and I'm going to plug it into my F function. If I plug 4 into my F function, I think I get negative 16. So now I'm going to take that negative 16 and I'm going to plug it into my H function. If I plug negative 16 into my H function, I'm going to get 1 over negative 16. That's not negative 31. That's not going to work. So that's a no. But then I'm going to follow with the same thing that I just did a second ago. Keep the first one locked in. Now maybe flip the other two. So let's do G, H, F. See if that works. So G, H, F. So I'm going to take 0 and I'm going to plug it into my G function. Okay, if I plug 0 into my G function, I think I get 4. So I'm going to put a 4 here. Now I'm going to take that 4 and I'm going to plug it into my H function. So this is me just doing scratch work off to the side. Once I feel good and I'm confident about the order, I'll fill in all of the machines stacked. Okay, so I'm going back. So 4 goes into H. So go back to H. Oh, okay, it's a fraction. I'm not thrilled about that, but maybe a fraction before the end is helpful because I don't want a fraction at the end. Okay, with the F function, if I do 4 times 1/4, 4 times 1/4 is going to be 4 over 4. 4 divided by 4 is 1. So I'm going to get 1 minus 32. So that's 1 plus negative 32. This is negative 31. I think we got it. So in going through this, trying to be organized and meticulous about listing down the ones that I've tried to make sure that I don't keep double checking the same one, because then it's a waste of my time. So I'm going to go back to my machines and I'm going to plug them in. And let's double check this. So I think I'm going to do G first, so the one that I just found that worked. So I think it's that guy. So G is x minus 2 squared. All right, so let's do that off to the side. So G of 0, so I'm dropping 0 in. 0 minus 2 squared. Okay, so that's 0 plus negative 2 squared. That's negative 2 squared, which we know is negative 2 times negative 2, and that's positive 4. Okay, so 4 is my output there. What was the next one we decided? H. Okay, so let's put my h of x function in here. And I think that was 1 over x. All right, so h of 4 is what gets dropped in, so I'm going to get 1/4. I'm not thrilled about the fraction, but looking at the functions, I was going to be stuck with a fraction anyway. G, F, all right, h is next. So this is 4x minus 32. All right, I'm going to go ahead and plug my 1/4 in. So f of 1/4 is going to be 4 times, oh, I didn't use my parentheses. Sorry about that. Times 1/4 minus 32. Gives us some more practice with fractions. Remember, you want to make sure that this looks like a fraction as well. And then we multiply straight across. So f of 1/4, that's going to give me 4 over 4. Bring the minus 32. F of 1/4. 4 over 4 is 1. Minus 32. I don't like the way that looks. I'm going to do 1 plus negative 32. And there's the negative 31 that I wanted. I got it. So although the previous slides may have been a little bit more challenging because we needed to figure out what couldn't be first or what couldn't be last, it gave me a better chance at figuring out what the order was going to have to be.